All right, last type of graph we're going to talk about is the cotangent graph. Now, I'm going to base cotangent as being the reciprocal to tangent. So I'm actually going to start, and I'm going to zoom in on the graph part of this. I'm just going to graph the tangent graph. So let's see. Let's go pink here. So let's go ahead and label this out. This is going to be pi over 2, pi over 4, 0, negative pi over 4, and negative pi over 2. Now, I'm going to go ahead and think forward a little bit more, and I'm actually going to finish filling these out. So this is going to be 3 pi over 4 and then pi. There is a method to the madness. 3 pi over 4 negative and negative pi. Okay, so the normal tangent curve would have vertical asymptotes. I'm going to try and make these pretty thin here. Would have vertical asymptotes here at negative pi over 2 and at positive pi over 2. And the graph would be, let's see, negative 1, 0, positive 1. So my curve would look like this and like this. And I'm actually going to go ahead and fill in the left and the right here to continue this. So this would be negative 1 and 0. So the curve would look something like this. And over here, I would have 0 and positive 1. So I'd have the rest of that curve right here. Okay. So this is it's 2 cycles of the tangent curve. You have 1 full cycle in the middle and then a half on the left and a half on the right. So what happens to find the cotangent graph? What are we going to do here? So we've got certain critical values. And again, this is actually part of what I knew I was looking for. So I've got 0, pi over 4, pi over 2, 3 pi over 4, and pi. So first things first. Because we're talking about a reciprocal, right? Cotangent is the reciprocal to tangent. So cotangent is the exact same thing as 1 over tangent of x. So immediately, if tangent of x is 0, cotangent is going to be undefined. So let's find the places on this graph where tangent is 0. And I'm just going to go ahead and throw in a big old vertical asymptote there. So we've got tangent 0 here at negative pi, right here at 0, and right here at positive pi. So this is the vertical asymptote for cotangent. And right here is, whoops, let's move that out of the way. Vertical asymptote for cotangent. Okay. Now, if tangent is, let's say, I'm just going to look at this right side right here. If tangent is positive 1, which it is right here, the reciprocal of positive 1 is, well, it's 1. Okay. Right here, tangent is negative 1. The reciprocal of negative 1, negative 1. Now, this one is a little bit weird, okay, because tangent is undefined here. Now, what does it mean for tangent to be undefined? Well, when we set up the division, it meant that the denominator was 0, and the numerator could really be anything, but generally that numerator is 1, so it was either 1 or positive, or 1 or negative 1, and the denominator was 0. So if I flip that over, I would create the fraction 0 divided by 1. Well, 0 divided by 1 is 0. So if I look at these critical values and I fill in my chart here, at 0, cotangent's undefined because tangent is 0. At pi over 4, cotangent is positive 1. At pi over 2, cotangent is 0. 3 pi over 4, cotangent's negative 1. And at pi, cotangent is undefined. That is an ED there. Okay, that looks horrible. Hold on a second. I had like 15 curves there. There we go, slightly better. So what does the curve look like? Well, it's similar to a tangent curve, but it's offset. Okay, so they don't, the vertical asymptotes don't match up. And in the case of tangent I always think of as an increasing function. So it's going to go -1, 0, +1. Cotangent's the reverse of that. So it's going to go +1, 0, -1 from right to left. So this is a decreasing function. Now, if I did the same thing over here on the negatives, I can match up the -1 and +1s. And again, where tangent is undefined, so there's that vertical asymptote for tangent, that is going to be a 0 for cotangent. So let's go ahead and graph that in. Now I'm going to go ahead and take out the curves for tangent and remove those vertical asymptotes so that all you're seeing here is the actual, there you go. So these are two cycles, two periods of the cotangent function. So you'll notice they're a little bit different than tangent. And just be careful that you understand like how the basic cotangent function looks compared to the basic tangent function. Now I'm going to go ahead and put back in the tangent graphs just so they're there and we can kind of see them for the key. Nope, that's what I wanted to leave. Okay, redo that. There we go. Amplitude. Yeah, amplitude is not applicable. All right, NA, none. So after everything that we've done, we've graphed sine, cosine, cosecant, secant. Now we've got tangent and cotangent. Sine and cosine are the only ones that have an amplitude. Okay, because secant, cosecant, tangent, and cotangent both, all four of them approach infinity, amplitude doesn't apply. Okay, period. The standard period for tangent and cotangent is a period of pi. All right, secant, cosecant, sine, and cosine all have a standard period of 2 pi. Tangent and cotangent have a standard period of pi. All right, we've got two quick examples here. Let's see what they've got. So problem number 5. Amplitude, period, phase shift, and vertical shift. So we've talked about this repeatedly. Amplitude doesn't apply, but if I did have a coefficient here, something in front of cotangent, it would stretch these points either further away from the x-axis or closer to it, depending on what the coefficient was. So let's say the coefficient was 2. Then I would multiply this +1 by 2, and all of a sudden I'd stretch this point all the way up to 2, and this point would stretch down to -2. So I'd just be stretching it further away. If, however, the point, that coefficient was 0.5, then I would be compressing these points half the distance to the x-axis to figure out where those critical values go. All right. Period here is going to be a total of pi over 2. How'd I find that? Remember, it's based off of that coefficient of x, and it's the same process. Take your standard period of pi, divide it by 2, so it's pi over 2. Phase shift, none. Vertical shift, we're going to go down 2. Okay. So the first thing I want to do is to put in my critical values across the x-axis. So the nice part about cotangent is you are going to start at the y-axis and then label 4 to the right. So we're going to go pi over 2, pi over 4, pi over 8, and 3 pi over 8. We're going to start and end with a vertical asymptote. So start at 0, end at pi over 2 with a vertical asymptote. And now I'm going to do a little X marks the spot. Normally cotangent is a decreasing function. So you'll notice I started with +1, 0, -1. So it's decreasing from right to left. But I need to take each one of those points and slide it down 2 spaces. All right, so down 2, 2, and 2. And take a moment and sketch in your graph. So you're going to curve up and to the left and down and to the right. All right, so that's your cotangent curve there. Let's go ahead and slide over to number 6. Let's see what we've got for this critical information. So amplitude, period, phase shift, and vertical shift. I keep saying it, but amplitude doesn't apply, right? Get used to just writing it in there, it's fine. Period in this case, no change, so it's going to be period of pi. We're going to go phase shift left, pi over 4. So remember, when it says plus pi over 4, you can either flip the sign or remember to take this whole expression and solve for x. So if we did that, we would have x plus pi over 4 is equal to 0. So x equals negative pi over 4. The negative is what's telling me to push it to the left, and then pi over 4 is obviously pi over 4. All right, vertical shift, straightforward one, up 3. So let's go ahead and label the x-axis here. So 1, 2, 3, and 4. Period's pi, so pi, pi over 2, pi over 4, and 3 pi over 4. All right, let's go ahead. Now, because this has a phase shift, I am just going to lightly put in one vertical asymptote there and there, okay? Because now I know I'm going to have to shift it to the left, and I'm also going to have to shift up. So let's do little X marks the spots here. I'll go in orange there. So normal cotangent, there we go, positive 1, 0, negative 1. Now, whoops. I'm having issues here. Sorry about that. So every one of these points is going to shift left pi over 4. So 1 space to the left and 3 spaces up. Now the vertical asymptotes don't shift up. They're vertical lines. They're just going to shift to the left. So let's go ahead and shift those to the left 1 space. And before I do anything else about that one, I am going to quickly go and label my x-axis. So negative pi over 4. Make sure you label all of your x-axis, okay? And each one of these, let's try that again. Each one of these little x's, I'm going to shift 1 unit to the left and then push it up 3 units. So 1 left, 1, 2, 3. 1 left, 1, 2, 3. 1 left, 1, 2, 3. All right, so those are my 3 points. Play, connect the dots. Remember cosine, these are all curves. Sine curve, cosine curve, cotangent curve, tangent curve. They're all curves. So please make sure you're actually showing these as curves. And yes, I will comment on them if they start looking too straight. Okay. So if you have any questions or concerns about cotangent, please let me know. If you have any questions or concerns about any of the graphing that we've